Chat. This is Eric Johnson Mission Control, EJ Mission Control, UHF Com Check. You guys, I don't know what happened there. My connection just started to fail. The OBS started to fail. That's very weird. It's not Twitch. I don't think, at least. We're not dropping frames. All of a sudden, the stream started to hemorrhage off frames really bad. That was very strange. I've never seen a failure like that. Yeah, maybe the ingest server crapped out. Anyway, this is the VV22 launch here. Launching the Pléiades Neo 5 and 6 here. And it's going, actually, they're showing the trajectory here. This is a Vega-C launch vehicle, which is a 4-stage Italian solid rocket booster with a Ukrainian, actually, 3rd stage called the Avum. And it's going to shoot Pléiades Neo 5 and 6 into a polar orbit here. So it's actually going to come up north kind of near me. We copy you. Got a bunch of guys starting balloon out here. We're breathing again. Yep. Yeah, Kyron. Yeah, that was very weird. I think the ingest server did take a dump, guys. But, yeah. Oh. You applied for a job at NASA today, Thomas? Right on, man. That's cool. What part, if you don't mind me asking?
My sequence. While we wait for this, I'd like us to take a closer look at the new Vega-C launcher. David, this new
CEO, just kidding.
On the 30th of July, but tonight
all right. I was going to say NASA doesn't have a CEO, homie. IT Systems Administration. Right on, dude. That's cool. Good stuff, man. I hope you do well. I don't know, Pinta. It's going to be high up in the air. So Vega-C is a good vehicle. This one is made by Avio. Avio it's an Italian company. So this is an Italian launch vehicle. It is a very nice launch vehicle. Grazie mille. Very nice. Ferrari upper stage. Do you want to go into orbit? Question. What about Pléiades Neo?
Tonight, on board Vega-C, Europe's newest launcher, are a special set of twins, Pléiades Neo 5 and 6. These two very high-resolution optical satellites will join the rest of the Pléiades Neo family. The first two of these satellites were launched last year by Arianespace.
So here, no, passionate but not reliable. No. See, you guys, you don't understand. All right. If you think about what a Ferrari does, it's very passionate and it goes very passionately fast and it passionately goes down the road, and then it passionately catches on fire and passionately burns to the ground. If you take that logic and you apply it to a rocket, then you have a very passionate ignition and a very passionate liftoff, and everything is on fire. And that is the perfect. That is what you want a rocket to do. You want a rocket to do that. That is what you want. You wanted to do that. So taking that mentality to rockets is a very, very good thing. There's a fiery passion and it takes off in a big ball of fire. Sorry. I'll go back to not talking like that. Hey, FN, 13-month resub. Show the rocket. I'll show you. Shut up, Jim.
Because it's really a very big difference from our current sensors.
You can't say that. It's a piece of crap. I can't say that. This is a piece of crap. All these facilities, and you make a piece of crap like this. No, seriously, Vega gets out of the hole real fast, dude. It's a pretty awesome rocket.
Optical imagery is increasingly attracting private players as well as government entities and startups.
He nailed Lauda, Hellfish. It was
Thanks to
perfect.
their remarkable responsiveness and agility, Pléiades Neo is also revolutionizing the field of maritime security.
What?
Helping to track down illegal
Are they launching from Italy? No. French Guiana, where we watched Ariane 5 launch. That was Hawaii.
Join their twins and the rest of the Airbus fleet in a couple of hours.
This is from
Last July,
French Guiana.
Airbus engineers gave the green light to an optimized configuration that will use the advantage of the enlarged.
Yeah, they say
Vega-C.
Pléiades,
The
but we
satellites
say
are
Pleiades.
linked only by a clamp.
Whatever. We're probably not
Once in
saying it right,
orbit,
man.
Pléiades Neo 5 and
You
6
can, you
will
may
be
passionately
the
change the
existing
hat.
Pleiades constellation.
Oh, garage stretch break, dude.
So we just heard Stéphane Legrand talking about a revolution in terms of resolution. Wendy, you are a senior manager for digital and European institutions and also our expert tonight on road to space. How long has Airbus Defence and Space been working on the Pléiades Neo project?
So the Pléiades Neo project was born quite a while ago in 2016, and over the years it's more than 1,000 people who've actually worked on the project.
I'm not out of
Well,
breath.
the Pléiades Neo constellation provides 30-centimeter high-resolution imagery of the Earth. Does there exist anything more efficient on the market today?
Actually, Pléiades Neo is the only constellation on the commercial market which combines such high resolution and that many revisits.
We are talking about the commercial and therefore civilian market, which is complementary to the military market. What is the legislation in this domain?
The legislation?
We abide by the French Space Operations Act, regulating authorizations and space licensing, as well as resolutions, for instance, of the United Nations. So with Pléiades
It's
Neo,
called the fishbowl.
we're actually getting closer
Jupiter
to
Mission
the needs
Control,
of the
French
military
Guiana.
domain. Let's
Yes,
say that we
yep.
complement existing military Earth observation capabilities. And to give you an idea of what we can see at 30 centimeters, we can see many objects such as cars,
That was as elegant
vessels,
as the Ferrari
aircraft,
pit strategy.
including specifics of their design
me,
to
dude.
distinguish the different types of vehicles and count people even.
Well, all the lights on the board are green. Wendy and David, can you confirm that everything is going to schedule?
This is the mission director.
Yeah, so
Stand
everything
by
is
for the
according
final
to plan.
count
We just
commencement.
heard the DDO announce. Yes, he just announced the start of the
T-minus 4
synchronized
minutes.
sequence.
Well, that's brilliant news. So the
Pepin
DDO
Antoine
has just confirmed
Gorlami.
the synchronized sequence.
Golami.
Perhaps, David, you can explain to us what this means and what is the next step before liftoff.
Is there any reason why the U.S. doesn't launch
That's
from
why
French Guiana?
dismantled
We
the
want
launcher
American rockets
systems
from
are
American
ready for
soil
the
to must.
mission. There is only some last operations that are performed automatically on the launcher. And
Do you know the Japanese
teams
name
are
for
fully
Pleiades?
focused on checking that all the launcher parameters are correct.
No.
And we'll be monitoring this green panel closely. But just before Vega-C lifts off, I'd like us to take a look at
Yes,
some
sir.
images of the previous launches of the Pléiades Neo satellites. And of course, the inaugural flight
Subaru?
of this new rocket.
Subaru.
Which took place on
Subaru,
July
isn't it?
13th.
It's
We
Subaru.
have some CGI images coming up. Sorry, we have some images coming up on the screen right
Yeah,
now.
it's Subaru because their logo is the stars. Yeah. 5 head.
They will be coming up in a minute. There, of course,
Subaru.
before we go to that, obviously we have Vega
Don't do that again,
sitting
Panaman.
there proudly.
I will
They're
hit you in the
coming up
face
a
with
minute,
Ding
David,
Chilling.
Don't worry. There we go.
Yes, so this is the images from the previous Pléiades Neo flights. This is Pléiades Neo 3 assembled into the fairing.
Don't do that. Don't do that again.
The fairing with a satellite on the launcher, and this was the first flight that took place
Hello.
in April of last year. And then
This guy sounds really
these are
happy
the
to be
images
here.
of the second launch that took place a few months later. Here too, with
Being
the
chilling,
integration
Daisha.
inside the fairing and the integration of the entire
Yeah, Hank, this
concept
thing,
on the
Vega's a
launcher.
monster. So the cool thing about
It's
it,
also
so Vega's, it's 4 stages. 3 stages are SRB. That's the first stage right there. The first stage is the P120. Look at that. Look at that. Vacuum optimized, gimbaled SRB. That was actually from Vega-C's first mission, where it launched the disco ball into space. So the first stage, oh, yeah, yep. Yeah, baby. So the first stage right there is the P120C. Fun fact, that's Ariane 6's side boosters. Disco ball! Did you see it? Disco, disco. So the first stage for Vega-C is actually Ariane 6's side boosters. which is actually really cool. That makes me happy because yeah, these things pack a pretty good punch.
Our turn, David and Wendy.
They're smaller.
to sit
Tony, Vega is a medium-duty launch vehicle, somewhere analogous to Antares.
À tous de DDO, attention pour moins 1 minute.
This is the mission director. Stand by for T-minus 1 minute.
Top, H0 moins 1 minute.
T-minus 1 minute. Top. Allumage 1 minute. So what you're saying is we should have kept Omega. What language is he speaking? Français. Parlez-vous français, s'il vous plaît? S'il vous plaît.
Discovery,
Plane.
go at throttle up.
Alex, 34 months. Merci beaucoup.
À tous de DDO, attention pour le décompte final.
This is mission director. Stand by for the final count.
10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5, 4, 3, 2, 1. Send it.
Top. Allumage P120, décollage.
Yeah, baby! I told you, you feel the passion. You feel the passion, chat. Look at the passion. The flames are coming out of the bottom. It is perfect.
La propulsion est nominale. Le
Forza
pilotage
Vega.
est calme.
Yeah, solids, man. Good times. Here she goes, man. She goes hard.
Discovery, go at throttle
Le
up.
pilotage est calme. La trajectoire est nominale.
The trajectory is nominal.
Acquisition de la télémesure par la station de Saint-Jean.
The telemetry, guidance and telemetry is good. I think that's what he said. He speaks too fast for me.
Paramètres bord sont nominaux.
How
Oh, okay, yeah,
fantastic
yeah.
to see
That's-
Vega-C
okay. Yep,
roaring across that
Acquisition of signal,
equatorial
St. John.
sky. Yet again, one can't take
Merci.
one's eyes off her. It's so impressive, like a boil of light rumbling across the jungle. This is, of course, the second launch of Vega-C, Europe's new launcher, and it has just
languages do you
successfully
speak?
completed
English
liftoff
and bad
with
English.
Pléiades Neo 5 and
Stand
6
by.
on
There's the
board.
tail off for the
These two
P-120.
satellites, designed by Airbus Defence and Space, are the
P-120C tail-off should be
to
happening
lift off on a
soon. That
Vega
may have just
launcher,
been camera
and we will, of
exposure.
course, be following the different stages of this flight very closely. David,
we're
I turn
fighting
to you.
bareback
What are the main
across the
stages
jungle.
of the flight?
Dude,
we
Katie
should be
Coleman
looking
is a
out
great
for in the
commentator,
next few
and
minutes?
I still wish
So in a
she
little
would
less
do
than
this.
1 minute, the P-130 first stage will have finished its job, and it will separate from the launcher. And then the second, this is the second flight of this P-120
Propulsion est
stage,
nominale. Le pilotage est calme.
following the maiden flight,
Propulsion's
and
nominal.
it will also be used on Ariane 6 later on.
Début de queue de poussée
Well-
du P120.
Before the announcement
Stand
of
by
the
for flame out of
separation of the
P-120.
P-120, just one word, sure, a reaction. Wendy,
It's always amazing.
There's the tail.
David,
Stand by
Your
for
word.
separation.
Yes, it's always incredible to see the liftoff.
There we
Staging
go.
confirmed.
so now we have
Yes, and
Séparation du P120 et allumage du Zéphiro 40.
There we
Okay,
have it. The
separation of the P-120C, ignition of the second stage.
Saw it very clearly. Well, the DDO has just confirmed this separation of the first stage. So if I've understood correctly, the
I'm not sure,
P120,
Sally.
David, is just one of the new features of this new launcher. Am I right?
yes, so besides this first stage, the second and the fourth stages, so the Zefiro 40 and the Avum, have also been improved,
Pilotage est nominal.
increasing their propellant capacity and therefore the overall launcher performance. And also, very important, the fairing volume has been increased, allowing the launcher to accommodate larger satellites.
Well, Vega-C is starting to lighten its weight and separate from its first stage, the P120. What is the next step for the European
So-
launcher?
Salyud, what you might be hearing from the pops when the rocket launches, that noise is the frequency of sound. Also combined a little bit with the Doppler effect. The frequency of the sound combined with the Doppler effect does create buffeting on the mic. It's like if you went, into a microphone, you'd get that same kind of noise. Rocket engines are so ridiculously loud, they really drown out everything else, and you usually get a popping noise like that. Uh-oh. Guys, premature flame out. Second stage shut off. Confirmed second stage shut off. The telemetry is no good.
In the next minutes and hours, we'll assess that both satellites are fully operational.
The Z40
This
shut off
means
too early.
checking telemetry
Telemetry
the
is
success
out
of
of
deployment
family.
the solar
Not
panels
good.
and so on.
Not good.
It's an
Not
in-depth
good.
check to make sure everything is nominal. Once that's done, we'll turn on the camera, which was one of the most fragile instruments.
Oh,
We
shoot.
see that there's a problem with the trajectory.
The X is out of the O. That's the nominal
David,
ground
can you
track,
tell
so
us?
that...
Yes. So there seems to be an issue with the launcher, yes. We stand by to get more information.
We never made it to Z9 ignition.
So could you tell us exactly? We can see on the graph in front of us, we can see that the trajectory, it seems to be going, maybe, is it going off course? Can you tell me?
So,
Yes, indeed, the altitude, it seems to be lower than expected.
So the altitude, we're at 107 kilometers.
the graphic is not telemetry
Have you got
different. This
any
is a
news
baked
from us from
animation.
Peru?
That's the
No,
actual
it is-
telemetry.
No, not for the time being.
So, in this type of situation,
The vehicle all coasted past apogee. They had a premature flame out on the Z9 second stage. Or not Z9, it was the one before that. And the vehicle is falling. The altitude is 94 kilometers. It's going to break up soon. It's going 3.36 kilometers a second now. It is decelerating from... It's decelerating from going back down into the atmosphere. But now we're starting to have an acceleration on the vehicle.
Yes, indeed. There's
Altitude is now 82 kilometers and decreasing. Distance 782. It looks like after flameout, it's following the ballistic arc here. We never made it to fairing separation, so the fairing is still attached there.
it was a very spectacular.
Unless it was sequenced correctly. They cut the audio. Hands on head, dude.
We can see the DDO.
Hands on head. Not good.
They seem very focused and still concentrated.
3.42 kilometers a second, increasing at 64. That graphic is incorrect. We had a signal handover, it looks like there, so we still have an acquisition of signal on the vehicle. It's still relaying data, guys.
Talking to
Oh God, this hurts when it happens.
David, we're still waiting for news
it's
from
flipping.
you. I don't think
Yes,
you have
We have lost a signal on the vehicle at 55 kilometers. The vehicle started tumbling.
All I can say is that if we do have to go off the air,
That's
we
it.
will, of course, be giving you an
C'est
update
fini.
on all our social networks, and we will be keeping you updated
Damn.
with what's happening. We can see once again everybody. We can see the VIPs standing around waiting to hear.
That blows, dude. That's so bad.
À tous de DDO, suite à accident lanceur, que tous les moyens restent activés pour une mise en configuration d'arrêt de la base de lancement.
What does that mean, David?
Yep.
What does the DDO just
Yep.
announced to us?
Yeah, so the DDO announced that there was indeed an issue with the launcher, and so everybody's standing by
You're not getting anything back, Tony. It's
on the
going 4
launch base
kilometers a second.
to
It's
see
not-
what
the vehicle
the
broke up.
exact
It
next
started,
step
situation
is-
is.
it started
yes.
flipping end over end and
Okay.
then disintegrated. You could tell from
they
the
certainly
telemetry.
look very, very focused.
So, guys, that's not good. That's not good for commercial launches. The reason why that's not good for commercial launches is because any launch that happens that fails is going to screw the insurance in the launch industry. and people will be less likely to take risks when launches like this fail. It's not good. It's really not good. It's not good for anybody.
For the time being, without additional information, but
what happened?
That, yes,
the second stage shut down. The Z4 shut down. It shut down prematurely.
An issue
Laser juice.
With this.
Would it be safe to say it's not a successful launch? It is not a successful launch, CJ. The telemetry doesn't lie. Telemetry and data doesn't lie. It doesn't.
Still waiting news. We're still very hopeful.
This was the second Vega-C launch, Joe.
Is going to be
what was the payload? 2 Pléiades Neo 5 and 6 satellites. They lost 2 satellites on there. I don't think it was thrust vectoring inversion just because of the ballistic arc that the vehicle took hypersonic. If it was wired upside down, it would have gone up. That vehicle was definitely not accelerating, and the rate of acceleration was in line with a ballistic trajectory, meaning that it hit apogee and then started accelerating and then started hitting the atmosphere and started decelerating and then accelerating again.
So obviously, people
I don't know, Victory.
Are waiting to get more.
How does an SRB shut down? Casing failure B0. Casing failure or off nominal telemetry from the flight computer. Dude, it when an SRB shuts down,
that's what we call the fishbowl.
Yes, inside there are the people following the launch and all the authorities.
No, this is Ariane Space or Kines.
The public and guests that are invited.
This means
can separate from its first stage, the P120.
So let's watch that. I'm gonna go back here in a little bit and we'll see.
In a few seconds, the Zefiro 40 stage.
That's not good.
Have finished also its job.
See those flames?
Will also separate
That's
from the
not good.
launcher. And the third stage, the Set 9 will ignite.
She's
and
spinning.
continue the mission.
She's spinning. The casing on the SRB. The casing on the SRB went. Look, the vehicle's doing this.
Have put into getting Pléiades Neo 5 and 6 airborne today and en route to their destination. But it's tonight that everything starts.
Oh, this is so hard to watch. I hate it. I hate it so much.
Involved in developing the satellite and those who will be.
And under pressure has been observed on the Zefiro 40, which is the second stage of the Vega. And after under pressure, we have observed the deviation of the trajectory and a very strong anomaly. So unfortunately, we can say that the mission is lost. And I want to deeply apologize towards our customer, Pléiades Neo and Airbus Defence and Space, for this failure tonight. And we will now have to work with all our partners to better understand why the Zefiro 40 has not worked properly tonight, triggering the failure of the mission. So we are going now immediately with all the teams, with our prime avio and all the partners to study what has happened tonight, and I really apologize for this anomaly.
Thank you, Stefan.
So, this mission was delayed for a month due to hardware issues. So, okay, let me rewind it from Stefan 1 second. I want to listen.
Can he explain to us the problem?
What did he say? I think he said an under pressure event was observed.
Yes.
So after the liftoff and the nominal ignition of the P120C, which is the first stage of the Vega, and under pressure has been observed on the Zefiro 40, which is the second stage of the Vega. And after this under pressure, we have observed the deviation of the trajectory and a very strong anomaly. So unfortunately, we can say that the mission is lost. And I want to deeply apologize towards our customer.
So SRB under pressure happens from the casing. The casing cracked. The second stage, it didn't pop, Tessa. I would need to see a picture. Hang on. I need to see a picture of that Z4. The Z4 took a dump. That sucks, man. That's so difficult to watch. You don't wish that on anybody. Let me see if I have a picture of... So, this is what we're looking at here. You have the P120C, the Z4, the Z9, and the EVM. The EVM is a hypergolic liquid fuel upper stage, but we have a 3-stage SRB right here. Tessa, what I'm looking for here... It's a single casing SRB, guys, so there's no O-rings or anything. Up there, see that plug-shaped thing? That's the igniter. The igniter for the SRB. You could have blown a gasket there, but it looks to me more from what I can tell, from what we saw, from the footage, it looks like the nozzle separated, guys. Yeah. The reason why they had a pressure drop. So this is a gimbaled nozzle. And the nozzle does move, and it kind of moves on like a ball and socket joint that goes over the throat of that nozzle right there. And don't get me wrong, you shouldn't jump to conclusions. But judging by how the plume was coming off the vehicle and kind of going like this, they lost the nozzle. The nozzle popped off. I'm pretty confident in that. That sucks. That sucks. Because, here, check this out. If we go back and take a look. Okay. So this is flame out right there. Separation. Good. That's good ignition. See how consistent that plume is? Watch. Do you think the nozzle actuator could have jammed? No, if it jammed Victory, it would have started spinning like crazy. This thing was doing something like this. So everything looks good there. We really just want to watch right here. The fuel, it's not the fuel, guys. It's not, you don't screw up the SRB fuel. That's not how that works. They lost the nozzle. The nozzle blew off. Which really sucks. The Z40 stage is a new stage developed for Vega-C. This was only be its second flight. Well, didn't fly very long. I don't see any wobble here, Trojan, but watch. Watch over here. You could literally see the moment the nozzle plops off. Right there. And see how the plume is expanded? The plume is very underexpanded because they lost the nozzle. I saw that on the way up, and I looked at it, and I'm like, well, it's a new stage. I don't remember if it did that or not. But look, no guidance. No guidance. It's just doing this. They lost the Z4 nozzle. I'm pretty confident in that. Guys, the reason why I can say I'm pretty damn confident in what's going on with that is the SRB has one moving part. Technically two if you count the igniter. You have the igniter, and then the thrust vector control. That's it. That's it. There's two moving parts. Well, actually, okay, so you have your X thrust axis control, so up and down, and then you have your Y thrust axis control, left and right. So if you include the igniter and the two thrust vector controllers, there's three moving parts. There's only so many things that it could be with an SRB. They lost the nozzle. The nozzle fell off for whatever reason. Precisely. Underexpanded. Please explain that for the noobs. So that's overexpansion? No, it's underexpansion, meaning that 619, because there's no pressure. There's no pressure with upper stage engines. You need a bigger nozzle, okay? You need a bigger nozzle with upper stage engines because there's no air up there. Why? Okay, so there's no air up there. So what does that mean? The bigger the nozzle, right, the more efficient you're going to get. Long story short, the really simple, easy way to explain it is think long tube headers, 619. Long tubes. Long tube intake runners. Same idea. If with the longer nozzle, because your ambient pressure outside is nothing, The bigger the nozzle, the more you can shoot the gases in one direction, because when the gases hit the end of that nozzle, they're just going to shoot out in every direction because there's nothing holding them together, because there's no pressure up there. As you approach the vacuum, a bigger nozzle is what you need. A bigger nozzle is usually what would be good, because you gain more efficiency. And that resulting phenomenon that happens from a larger nozzle like that is, you get what's called under expansion, right? Well, actually, it would be it goes from overexpanded to underexpanded when the nozzle pops off. Basically, it's just a spigot and it's just shooting gas everywhere. They lost the nozzle, and they may have lost the bottom casing of the booster. Like that, something went very, very wrong right there. See, so basically the plume goes from a nice vectored shape because the nozzle is shooting it out in one direction, and when the nozzle goes, it just starts going all over the place. This is a pre-rendered video. That's a live shot, and then the telemetry that you see down here from the Europeans is always live. No, Tessa, it's an early flight for this thing, but watch, you could see it when it goes. Watch right there. It's hard to check it exactly, but watch here. Right at T plus 3 minute. Oh, 3 minute 26. Yeah, the nozzle fell off. I'm like 90% sure they lost the Z4 nozzle. See how the fire's going all over the place, 619, because there's nothing to shoot it in one direction. Hellfish, this is your fault. Bad juju. Do you think they messed up during development? Robotical, honestly, the Z4 is a new stage. It's a new stage. New compliments is a Vega-C. It's the second time the stage is flown. You're going to have teething problems. It happens. No backup nozzle to take over. Rockets usually don't have secondary nozzles, Dragon, because you're not intending for the first one to go. I mean, 619, check this out. Look. So the thing about this, guys, is if you don't have that nozzle to push the gases in the right direction, they're literally just going to go everywhere, and you will lose thrust immediately. In order for a rocket engine to work right, you need what's called a convergent divergent rocket nozzle. Okay, so this is getting into some hardcore stuff. Long story short, you need to make an explosion big enough in the combustion chamber to pressurize it, and then it needs to go through the converging section. The gases need to get accelerated past the speed of sound inside of the throat, and then they go back to subsonic in the diverging section. Okay? If you just have the diverging section, if without the diverging section you just have a convergence section in a throat, think CO2 cartridge. It's not very efficient. You are going to lose thrust immediately. So your mass flow rate basically goes into the toilet. Yeah, bad. That's not good. So they lost it right here at the diverging section because it looks like it's over a nozzle, right? It looks like it's converging over the nozzle, but yeah. If it breaks off right here, the gases can't accelerate past Mach 1. Your mass flow rate, which is the flow rate of mass going past the throat of the rocket engine, goes to hell. Yeah, you lose thrust. It's like an immediate loss of thrust, like shutting the engine down. And right there, because they lost flow right here, the combustion chamber pressure dropped instantly because you're not pressurizing the gas. A rocket engine is just a big Venturi. If you don't pressurize the gas and it doesn't go supersonic in the throat of the rocket, you made a nice flamethrower. You don't make thrust. This is like basic of the basic of the basic of the basic rocket science. This is the simplest stuff. Basically, make an explosion big enough and then squeeze it out of the nozzle. If you miss the squeeze it out of the nozzle part, your rocket engine doesn't work very well. I get what you mean, what you meant or somewhat. The expulsion of gases from the burning rocket fuel is combusted in the chamber and then sent out at speeds to help push the rocket forward. Without it, the rocket is essentially useless. Yep. Thinking about playing City. Saw you play it yesterday. How's the new DLC? Fun. Sounds like the nozzle is similar to a tail fin on an airplane. No, not really. Yeah, Tessa, I don't care. I don't care. So yeah, if you don't get that what's called that convergent divergent flow, you're screwed. And then 6192, go into a little bit more about what I was talking about here. This is another picture. So the under and over expansion happens at the end of the nozzle. So if you have an under expanded plume, right? It's basically shooting out and then going out like this. That's under expansion. Over expansion is when the plume goes in, where this stuff goes in. So they went from basically good over expansion to insane under expansion immediately, because they lost it right at the throat, and you're getting no. Yeah, that basically the flight goes. The SRB basically blew up. The bottom of the SRB exploded though, which is why it didn't blow up the entire vehicle. The physics doesn't lie. The telemetry doesn't lie. I'm pretty damn sure that's what happened. Under expansion isn't a bad thing though. No, it's not. You want under expansion on upper stages. You want that, just not to that level. You need to be able to accelerate those gases in a direction. If you can't accelerate it in a direction, you just have the throat. You made a nice flamethrower. Yeah. Theoretically, 619, you could get infinite efficiency by making a nozzle that's infinitely big. But honestly, there's space constrictions on a rocket, so there's only so many ways you can make a rocket nozzle bigger. You know what I mean? That sucks. I feel for our European buddies. That sucks, dude. You don't want that happening. Did you miss the launch? You missed a rud, Hangman. Thing blew up. Yeah, that they lost the nozzle. I'd have to look at it like an actual picture of a Z4. Maybe they showed it. Maybe they showed like pictures of it being put together or something. Oh, dude, it hurts, man. It freaking hurts. Let's see. Here's some footage from integration a little bit earlier. You can't do it infinitely large. Well, if you're in the vacuum soapbox, yeah. I mean, it's theoretical infinite expansion. Yeah, you're going to get flow separation in atmosphere. Yeah, absolutely. We were talking about vacuum engines. Yeah, see? See what I mean, guys? See how simple this thing is? Look. You have a nozzle, and their nozzle goes around the throat, like a ball and socket joint almost. That's hollow in the center. There's a big ball joint right there. And then you have X and Y axis TVC. That's it. That is it. If this whole thing pops off, you're screwed. And I think that was actually a Z4 there. Hold on. So that's the P120. That's the disco ball. That was the first flight. Yeah, it was this guy right in the center. That sucks. That sucks so hard, dude. That sucks. So it's back to the drawing board? No, Bellum. What Kness and Arianespace... so what Kness needs to do, what they need to do right now is they need to figure out why that happened. So there's 1,000 different things. There's 1,000... Even though an SRB has only 2 or 3 moving parts, there's 1,000 different damn reasons why that could happen. Is it a manufacturing defect? Is it the design? So design, manufacturer, quality assurance, you have to do what's called a fault tree analysis. So basically they have to go troubleshooting a rocket that already exploded. That's it, and you're not getting the debris back, it's at the bottom of the ocean. That sucks. Sorry, I just got here. What happened? The Vega-C launching Pléiades Neo 5 and 6 just blew up on the way up. Well, it didn't blow up. They lost the nozzle. The nozzle on the rocket engine popped off. Avio and Arianespace. Kness is a satellite operator. That's the right... Yeah, sorry, Deadbringer. My brain's going into overdrive because I'm trying to think of explanations on the fly. I wasn't exactly planning on this thing to pop like that. So they have to go and do a fault tree analysis. You got to look at the telemetry. You got to look at the data. You have to be able to conclude... You have to be able to conclude what happened. You have to know what happened. If you don't know what happened, then... no one's going to want to launch on your rocket because you don't understand what you made. So they're going to do a fault tree analysis. Don't get me wrong, Arianespace knows what they're doing. They know what they're doing. They'll fix it. This is a new rocket. It's going to have teething problems. That happens. My guess, and guys, this is the most important thing. My guess doesn't mean dick without the data behind it. It means nothing. My guess is as good as yours is if I don't have the data to back it up. This is what rocket science is all about. My guess is because the first Z4 stage worked fine when we watched the first Vega-C launch. This is most likely a manufacturing or a Q&A problem. Most likely. I would say it's one or the other. This is not a design problem because they had a Vega-C. The first Vega-C launch worked just fine. It worked great. It launched that disco ball into space, which was actually pretty cool. No, it had 2 commercial satellites on it, Steve, and those satellites were not cheap. Oh, there's nothing underneath it. They make sure the track is okay. The freaking nozzle came off. Forge. I'm like 90% sure. But, once again, we'll hear from Arianespace, or we won't. I don't know. Hopefully it doesn't come down to them dropping it during integration or something. Bill, this screams QA. It screams QA. It screams quality. It screams quality assurance. This RUD is most likely somebody on the ground not doing their job during integration and testing. I could be wrong. I'm guessing. 100% I'm guessing. And if you're an actual rocket scientist, you should never guess. I want to drive that point home. Do not guess. Guess when you're absolutely desperate. Too much passion. I'm sorry. Oh, we were talking about it, Natch. We jinxed it. We jinxed it so hard, man. I feel so bad. It's tough, man. Yeah, so at about 2 minutes or 3 minutes and 20 seconds, 3 minutes 26 seconds, if you watch the Z4, it's working just fine right there. And then boop. See that? Oh, the entire nozzle. Yeah, they lost the nozzle. Actually, let me look at this. So, fellas, I'm looking at this. Forge, let me see that. We have a GIF of this. Oh. It's tough to watch, man. Oh. So, Forge, let me zoom back a little bit. Watch. I see... Oh, no. No, I don't need to share that. Not right now. I see an initial puff, and then the thing fails completely. Right? There. And then... Boop! Yeah. If I had to guess, fellas, that's probably the nozzle. That's probably the nozzle extension coming off, and then the nozzle failing completely. If I had to guess, because the Z4 has a nozzle extension on it, and then so that's probably this assembly coming off, and then this piece came off. This whole thing from basically here back, that all came off, and then once again, without a throat attached to the SRB, there's no. Oh great, you made a nice flamethrower, and if a flamethrower could exist in a vacuum condition, that's exactly what it would look like. And you can see the vehicle has loss of control, so it's just kind of basically spiraling along like this. That's hard to watch, man. How this will affect other companies, Exiled? Insurance is going to go up, and it's going to make it harder to, it's going to make it more expensive to launch commercial stuff, dude. Oh my gosh, that thing's turning out of control. You know what it reminds me of is the Omega test. That was for a different reason, Forge, but yeah. So it looks like the rocket flamed out because if I'm looking at that right, it flamed out because if you lose all of this, you have a much bigger opening here, and basically the SRB just burns out. It burns out. It can't maintain combustion chamber pressure, so it'll just flame out. Oh, that sucks. That sucks. It sucks so hard, man. Because you could see that the engine completely flamed out at 4 minutes right on the dot. And separation of the Z40 was supposed to happen much later in the flight. But the crazy thing about this, guys, is that you could see instantly when they bring the telemetry back up, right when that nozzle popped off, there's an immediate loss of thrust. Watch the X diverge from the circle. With the European Space Program's telemetry, that X needs to stay inside of the circle. The circle represents an imaginary road into space, okay? So the road is cylindric, and it goes all the way up. It's a flight corridor, basically. Think of it like just a big tube. If the rocket goes outside of that tube, it's entered off nominal. Basically, it's getting itself into a condition where it will not have enough thrust to make it into space. If it goes outside of the circle, if the X goes outside of the circle, you're screwed. You are absolutely screwed. And right after that nozzle pop, you immediately see a loss in thrust and a divergence here, which really sucks. And the flame out there matches the telemetry completely. That thing is making no thrust, and it's spiraling out of control, which... it's hard to watch, dude. It's hard to watch, but it's good to learn. It didn't stage port. The nozzle in the Z4, the whole bottom of the SRB exploded. Pléiades Neo 3 and 4 flew solo, but they decided to stick 5 and 6 on this launch. Those satellites are not cheap, Phil, from what I understand. That's right, Admiral. You're not wrong. I missed it. Are we sure it was the second stage, or is there potential issues for their up-and-coming big rocket? It was the second stage, Aqualex. The P-120C performed perfectly, from what I can tell. Yep, hands on face, textbook. My rule of thumb always is that if they don't show any telemetry, you can always look at the flight directors and the mission controllers. If they're doing stuff like that guy is in the background, you got a big problem. If they're doing the not like this, the or oh frick, or this or that, something is very wrong. That means the mission failed. If they're doing this one right here, the kind of, why is it doing that? That means the mission isn't going right. It's not going as predicted. If a flight controller is sitting there just doing this, watching the telemetry, everything's fine. But see the guy in the background? The guy in the background that's very telling. What if they're doing Monkas? That means there was a catastrophic failure. If you see a Monkas, that means something went very wrong. Did they have any plans to human rate Vega? No. Oh, that dude, it's so hard. I saw the second I saw this thing start to go, well, no, I noticed a problem right around here. Right here. So about 20 seconds after. Because sometimes the reason why is I'm watching this. Sometimes there's just a ground station handover and the telemetry, the X goes outside of the circle. When I saw that X fully go outside of the circle in real time, I'm like, yeah, that failed. Yep. I don't ever want to say the rocket failed and then have it go into space. I have to wait till I'm absolutely sure. So I was watching these numbers here. I was explaining something to somebody and then I looked back over here. I'm like, yep, that's done. Don't companies have spare satellites that are almost done, but not quite, just for these cases? It depends, Salyut. It depends on the... it depends. These are the last satellites, so they might have a spare left over. But yeah, that's RUD right there. That's RUD condition. The thing's toast. And then if we go a little bit further, you could see that a huge loss of thrust. The computers probably terminated it because the onboard computers on Vega probably understood that the vehicle wasn't going in the track anymore, so they probably didn't even bother. The computers didn't even bother to fly to fire the Z9. The computer basically just said, "Screw this. We're not doing this. We're not flying correctly," which is right. That's the right move. $1 billion of payload. Well, that just bankrupted an insurance company. Yeah, Victory. There you go. How can they terminate an SRB burn? It just burns until there's no fuel. This SRB self-terminated itself, Jim. That's the right way to say that. Oh, that sucks so hard. Yeah, the guy in the back knew. The guy in the back was like, "We're done. We're done here." Yeah, right now those two are taught. See? That guy's like, "Oh crap, that's not good." And he's probably saying, "You seeing what I'm seeing?" Yep. Yeah, that ballistic arc indicates an immediate loss of thrust. Guys, I know I'm saying it once, I'll say it again, like a broken record. I'm saying it in case anybody's popping in and understanding what's going on. I'm not just saying that to reinforce my own suspicions. I'm saying it for the people that are popping in and wondering what the heck they're looking at. The nozzle blew off. The nozzle on the SRB popped off completely, like complete separation. You don't want your nozzle to separate. That's like as good as having your tires separate on your automobile. That's happened to me. I can assure you it is not fun. Yeah. It went ballistic. Yeah, it's following its ballistic arc. That's right, Uncle X. Yeah, when you see that, oh, frick. Taking the glasses off? Yeah. Except you only lost one. Yeah, that's right. How do you terminate an SRB? There have been inerting systems, Salyut. All you got to do is find a way to lower the chamber pressure. You can have a blast cap on the top that can pop off if you want to inert out your SRB. The problem is that flames come out the top, so... yeah, that sucks. Arianespace says in an email the failure took place at 2:27. They lost the nozzle. Yeah, someone. And then, guys, you could see that they still have a signal lock on it. Look at the telemetry over here. If you look, the X starts doing this. It starts going... that's the vehicle tumbling end over end. The thing is literally coming back down and hitting the air. And because the center of mass is on one side, and it was spinning when the Z9... it was doing this, the thing ended up tumbling end over end. Watch the X. Yeah, I am speaking from experience. The 97 had a wheel fall off in Oklahoma. See how it's starting to get jostled? See how the X is starting to do that? Yeah, it's the vehicle flipping end over end. Oh, that sucks, dude. Oh, this is I hate doing this. I hate doing this so much, dude. It's so see, look, flips end over end, keeps flipping, spins get faster and faster, and then the telemetry goes blank. So we have loss of signal on the vehicle. Last transmitted telemetry for the vehicle ripped itself to pieces. Altitude 47 kilometers, going 3.1 kilometers a second, so 3,100 meters a second. Give me 1 second. $3,100 meters a second is 7,000 miles an hour, or 11,160 kilometers an hour, or 10,170 feet per second. Yeah, that thing obliterated itself when it hit the atmosphere. It re-entered. Yeah, not a good day. Not a good day. We can look at the speed change to see what G's it was under. Let me take a look. Oh, geez. Look at the deceleration. Oh, and then acceleration? Yep. Oh. Oh, that nothing good happened to that thing, Aqualux. Did you see that? Did you see the deceleration and acceleration? That's probably because it flipped right at the end and just shattered into a bajillion pieces. Hit the soup. Oh, that's bad. Yeah, here. We'll look at it at the end again. It didn't bounce, Poker. What you're seeing is the thing flipping. It's flipping end over end, and as it gets closer to the atmosphere, the atmospherics will start to stabilize it out, and it looks like it flipped one last time before the atmosphere kind of flipped it. The aerodynamics flipped it back over, and when it flipped it back over, the thing exploded. Oh. Here, let me back it up. Like, watch this watch the deceleration that happens right here. So they're going 3,300 meters a second, and in 1, 2, 3, 4, 5, 42, 55, 54, 49, 48, 66, 59, 35, 41. Yeah, it's flipping. It's tumbling. That's tumbling right there. It's because the IMUs that are on board are detecting acceleration and then deceleration and acceleration and then deceleration. And then at the final second, you get an insane deceleration, which means bye-bye. Any islands out there? No. No. Just to confirm, is this from today's launch or of the new Vega, or is this old footage? No, we watched it pop in real time. They lost the nozzle. Okay, let me say it officially. There was a malfunction on the Z4. The Z4 second stage, it had a malfunction. And Arianespace said they detected a loss of pressure inside of the SRB. So someone watch right there, okay? Watch right there, right at the point of the mouse cursor. Watch close. What can you tell me about that? You're getting textbook under expansion at high altitude. Huge under expansion, and the vehicle's definitely doing this. So, what do we have there? We have a loss of control. The thing has no gimbal. It has no gimbal. We have a loss of control, and you can tell from the telemetry that there's an immediate loss in thrust. The Z4 is a single casing SRB. That thing. It's a single casing. See, it's like a scuba tank, almost. There's two holes. There's one at the top for the plug for the igniter. That's basically a small rocket engine that fires into the chamber, lighting the SRB fuel on fire. Fun fact, they usually have a smaller igniter for their igniter. Yeah, a lot of SRBs have a staged ignition system. So you have one igniter, that ignites the bigger igniter, that ignites the engine. Because it's hard to get that thing to pop off right away. So, that's the top part. The only other part down here is the plug where the gimbal joint is, because this has thrust vector control. So, it's not necessarily a gimbal, it's TVC. And the nozzle goes into the throat. See that right there? This entire assembly came out. This whole thing back here popped off. In fact, you could see it. You could see when it happens. At 326, actually right before it, if you go back over here, watch at 323, you see a puff right there. See? See how it gets brighter just for a second? You see a puff. My guess is that that's the nozzle extension failing. And then right after that, boom, the whole bottom assembly comes off. You get super under expanded plume and an immediate loss of thrust. Think of it like if you had like a scuba tank, guys, and if you know, a scuba tank has a pressure regulator at the top, right? You open the meter and right? Think of that whole thing coming off. How quickly all the gases will come out. That's literally what happened. It starts with a little Estes rocket igniter. Pretty, yeah, kind of. Left right after the anomaly. Zay, I'm pretty sure they lost the entire nozzle. Unrelated, I noticed some weird plume behavior not long after liftoff. Wonder if there might be anything of note with that. Weird plume behavior. Let me see. That's just the exposure right there, Raj, on the camera. I don't know what that is, but this is a different system. I think Vega-C just thought it was Omega. This is the first stage. That's the P120. I don't know what that is. I think that's just the camera exposure. That looks all fine to me. This looks fine. You're getting perfect under expansion there. So see how the plume just goes a little bit out of where the nozzle is? It's just, so the nozzle has like an angle and the plume comes off of that angle and it kind of flows back inward on itself right there. It kind of looks like an hourglass. That's perfect. That is perfect performance. That's exactly what you want. The plume should be very, very crisp when a rocket engine fires. It should be very defined. If it's not defined, especially for like a first stage motor, it should be very defined like that. If it's not, then yeah, something's wrong. Could the rocket be passing through some fog? Yeah, maybe. This all looks real good. That looks fine to me. This still looks good. So, as you go higher out of the atmosphere and pressure drops, your under expansion gets bigger. See how now it's kind of, the plume's kind of going outwards and then coming back in? There's still a little bit of pressure to make the plume collapse in on itself. But there's not, that's going to gradually go away. And the plume will get bigger and bigger and bigger and bigger. Actually, there was a point where they had the camera exposure pretty much right just a second ago. Let's take a look. Yep, you can see it. See the plume? It's perfectly crisp coming out of there. See how it's really defined, and then it starts to go. As it goes out, it starts to get a little fadey. See how that's perfect? That's good. That's good ignition right there. Could the rocket be passing through some fog? Yeah, it's possible. It's possible. Yeah, see, this right here is the camera operator screwing with the exposure. See how it's a different color, but see how it's still crisp coming out of the nozzle? That's perfect, dude. Very good. Oh, see? Still crisp as hell. Look at that. It sucks because that's great performance right there. Dude, you can't ask for better than that. Yep, see how the plume, see how much it expands up there? This flow phenomenon is perfect. That's just some turbulent gases coming out of the engine. That's normal. That looks great, man. Great performance from the first stage. Seriously. You know, I mean, I was about to say they should be proud of this, but they're not going to be proud of this because the second stage didn't work. So as you go up, you will get overexpansion with the first stage. Underexpansion goes up. Overexpansion, 619, it's kind of like backwards, dude. So okay, so think about it in terms of the explosion coming out of that throat filling up the nozzle. It's just like a plenum on an intake manifold. You want to fill it up. If you don't fill it up, you're robbing power, right? Because you're going to create drag in the intake runners. You don't want that. Just like a car. I'm telling you, it's the same thing. It's the same thing. So with the nozzle, you want to fill up the entire nozzle with hot gases. You fill up the combustion chamber with explosion. And then what you get after the explosion is hot gases. You want to fill up the entire nozzle with hot gas. if you're not filling up the entire nozzle with gas, like what Soapbox Rocket said in chat, he's right, you're going to get what's called overexpansion. The over and the under expansion refers to the nozzle, not necessarily the gases coming out. So an overexpansion means you didn't fill it up enough. Underexpanded mean you filled it up enough to fill up the nozzle, but depending on how the plume comes out of the nozzle, you could have too much underexpansion. This has to do with basically your mass flow rate and the impulse of gases coming out of the nozzle. Basically, the plain English way of saying it would be filling up the nozzle with hot gas. That's all. Like you fill up a funnel full of oil. Same idea. Only one's a liquid and one's not. You get what I'm trying to say. So your under expansion will get bigger and bigger if your nozzle stays the same but pressure drops, right? That's why we see that plume expansion going on. Now, that Z9 was perfect. It had good under expansion for the nozzle because you saw a really defined plume coming out of it. And then it started to look like a sprinkler, like a hose head, where if you put your thumb over the head of a hose and water shoots everywhere, then it started looking like that. You get too much under expansion, which means you don't have any nozzle, which means death. This was the second Vega-C launch, Ford. Yeah. Mm-hmm. Oh, wait, that was staging. I thought that was the failure. Sorry. See, look at that. See how defined it is? That's perfect. That's working correctly. And then watch at 322, you see a pop. You see them lose something. Yep, there's a pop right there, and then boom. Super under expansion right there. Better diagram. Yeah, Oculux, that'll do us right. Thank you. Here you go. Take a look. So an underexpanded nozzle is where the pressure coming, the gases filling up the nozzle is greater than atmospheric pressure. Ambient is when they're the same. Then you have overexpanded and you have grossly overexpanded. Grossly overexpanded blows up rocket engines. You know why? Because you get such non-uniform heating here. The metal, the materials in the motor don't know what to do. That flow separation can break rocket motors. And by break I mean explode, because the thing will just. So gross overexpansion like this is, and Oculus, thank you for this diagram. This is perfect. Gross overexpansion like this is what happened to Omega. The Omega booster test, they had gnarly overexpansion, and the nozzle literally voided itself on the test stand. We watched it. We watched it shoot the nozzle off into pieces. So we went extremely underexpanded here because this part went bye-bye. And see how the gases just fill up enough to fill up the nozzle and then a little bit more. That's what you want. You want under expansion like that with any of your nozzles. But atmospheric pressure is dynamic, so that changes. So how the frick do you keep your chamber pressure good? You can either just have a chamber pressure that's way greater than any point of atmospheric pressure, which is what most rocket engines do. Or you could have a second stage with a different nozzle so you get the correct under expansion to go with the pressure. This is why second stage engine nozzles are different than first stage engine nozzles. Or you could really, really go the hard road and make something that can do anything. Check this out, 619. Look at the plume coming out. See? The nozzle is shooting it kind of downward. It goes a little bit out, just a little bit, and then moves back down. Perfect under expansion. That's perfect. That is perfect. See what I'm talking about? Or use an arrow spike. Yeah. The shuttle engine nozzle, if you notice, it's not an upper stage nozzle, but it's not a first stage nozzle. The shuttle nozzle is a hybrid. It's a hybrid. It's a little bit of either one. It's a hybrid nozzle because shuttle engines ignite at liftoff and go all the way up into space. The nozzle geometry of this is light years ahead of anything else. The only thing that even comes close is Raptor. In fact, I think Raptor might be a little bit A little bit more crazy than the shuttle engine. But you guys want to see something interesting? For all you SpaceX fanboys, look at the nozzle geometry on the Raptor vacuum. Boy, does that look familiar. Damn, that looks real familiar. The expansion ratio. That looks awfully familiar. Funny how that works. Don't get me wrong, SpaceX didn't copy the shuttle or anything. It's convergent design because there's only one type of nozzle that you can make to perform at any altitude. But if you look at the curve, so the curve of the nozzle, guys, so this shape from the throat all the way to the end is what's called an expansion ratio. With a different expansion ratio, you get your different geometry of nozzle, right? This right here, that's a hybrid nozzle all day. You see how it starts off really steep and then it's parabolic. It gets straighter and straighter and straighter over time. This is a hybrid nozzle. This can work down here, and it does. It can work down here and it can work up there. The expansion ratio is almost exactly the same as the shuttle. It's very, very freaking close. See what I mean? Somebody did this comparison, and look, see the nozzles? They look very, very similar. Yeah, the shuttle engine had a lot of they had a lot of practice with the shuttle motor to get it. It's still a complicated design. So what you're seeing here in this particular thing is a resonant frequency being introduced due to flow separation inside of the nozzle. Yeah, this is what I mean when I say overexpansion kills the nozzle. And the... Yep, okay. Yeah, that didn't work. Yeah, I think it's safe to say that didn't work. See? Look at the plume. Look at the plume coming out of the engine. You can tell. It's just like looking at a spark plug on an old car. You can tell everything about how a rocket's performing by that right there. Just looking at the plume. I mean, don't get me wrong. They use the telemetry. I'm not suggesting that there's some rocket whisperer out there that can just... yes, your turbine machinery is wrong. No, but this tells a good story right here. It tells you more or less what happened. That's why I can predict basically what happened with that Z4 before it happens. I'll tell you, the nozzle exploded. They blew off the nozzle like this. See? See the plume? The plume is overexpanded. It's cavitating inside of the nozzle, and bye-bye! Yeah. No good. It's almost like this stuff is complicated. Anyway, so if you're just tuning in, guys, the Vega Pléiades Neo 5 and 6 mission failed. It failed badly, actually, because the nozzle did something like that. There's also what happens if you throttle down too far. On certain rocket engine designs, absolutely. Yep. That nozzle wobble is freaking terrifying. Oh, yeah. Oh, yeah. Want to hear something messed up? That footage is just from them turning the damn engine on. That isn't them trying to throttle the engine and getting cavitation. That's them just trying to start it. Because if you don't start the rocket engine fast enough, right, it's just going to wiggle itself to pieces. This is the case with most rocket engines, guys. You really have to... That's part of the reason why they thermally condition the engines, because you got to start it, and it needs to be started fast. If you don't start it fast, stuff starts shaking around, and it starts shaking in a way that you don't understand, and then the thing blows up. Yeah, it's like trying to accelerate a freight train, like an entire freight train in like a split second. It's really difficult. Not that that's even possible, but let's just attach rocket engines to freight trains. Good call. Wait a minute, you mean rocket engines require rocket science and aren't simple in any way? Well, John, yes. The concepts are simple. I could, like, you guys understand, like, if you've been sitting here listening to me, mass flow rate, over and under expansion, cavitation in the combustion chamber, that's easy to understand. Literally, you don't fill up the nozzle with enough hot gas. That's it. In the case of Vega, you can't fill up the nozzle with enough hot gas when there's no nozzle, because the nozzle failed. It's not rocket science, man. Best part is no part, maybe? No, nope. Yep, nope. That's not how that works at all. attaching rocket engines to freight trains were possible, the Soviets would have tried it. You know, they attached jet engines. They had no problem putting jet engines on there. Did you all see the stocky space? What? Oh, Stoke. Yeah. Mm-hmm. Those things are cool, short line. I remember those. Is he running out of hats yet? No, well, anyway, either way, Arianespace will figure it out. It's a relatively new vehicle, guys, so I wouldn't be too like, oh my gosh, they're screwed. This will make insurance premiums go up in the spaceflight industry, which sucks. That's the part that sucks. And this is what I mean about when I say, you know, if any company fails, any commercial spaceflight venture fails, it hurts the industry. That's not good for the industry. If any spaceflight infrastructure comes careening out of space, out of control, and hurts somebody, that's bad for the industry. And it's bad for the industry in more ways than one. Even if it is another country, it's still not good. This is not good. I wouldn't wish failure on anyone right now. Commercial spaceflight's getting to the point where it's like solidified and just a pillar of economic, you know, profit, right? But they said that commercial spaceflight was going to be the new thing in the 90s. And then 1997 happened, and that went down the drain really fast. We're still not at the point where I'm comfortable enough to say that spaceflight isn't going anywhere for a long time. And don't get me wrong, it's still not going anywhere, but I don't want to go back to 6 launches a year and all of them be Department of Defense launches and cut the cast after 2 minutes. That was lame. That was not fun. What happened in 1997? The dot-com bubble, Sith. There was a huge bull market from like 1990. Actually, the bull market basically went from about 1989 to 1997. Straight bull market. Nothing but growth. It's called the dot-com boom. There was nothing but growth because everything moved to computers and everything moved to the internet. Basically, our modern world, how we think about it nowadays with internet infrastructure and whatever, was kind of forged in the 90s. I mean, don't get me wrong, it could trace its routes back to the 50s. I understand that. I know I'm not a total schmuck when it comes to IT and networking. I'm not terrible at it, but not an expert at it by any means. Not like I am with rockets, right? But the dot-com bubble burst. You know, the market went bust. It happens. There are ebb and flows to the economy. It goes up and goes down. It's just how it is. It's a living, breathing thing, you know? Well, we make it a living, breathing thing, but that's another story. So the dot-com bubble burst in 1997, and there was a huge recession in 97, 98, and then into 99. And then market started to recover. It part of the ways, you know, they started to recover, and then it tanked again in 2008. This is what I mean. It goes up and it goes down, and it goes up and it goes down. That happens. That's the norm. Hey, Jay, just heard about the Vega-C failure. Is this likely to delay Ariane 6? I don't think the problem was with the P120C username. I think the problem very much was with the Z4, which is not part of Ariane 6. So, no, I don't think so. Well, as a Rocket Labs fanboy, I'm staying the course. Not a good week to put my money where my mouth is. Hey, it's wins, dude. That's out of your control, Exile. That's out of their control. Rocket Lab, bro, the rocket's made out of carbon fiber. It's super freaking light. And because it's a small small sat launcher that's made out of carbon fiber, it is extremely susceptible to wind shearing loads. Because carbon fiber doesn't bend, it shatters. This isn't rocket science, man. This is just straight element analysis. Can't launch in the upper level winds. That's no problem. You just launch in January. I wouldn't say that's a mark on Rocket Lab or how it operates as a company. Talk is cheap in spaceflight. Then, anybody could sit there and say, oh, I'm going to make an SSTO. Okay, freaking do it. Then what? You know what I mean? Rocket Lab, if anything, has put their money where their mouth is more than anybody else has at this point. Seriously. How many commercial providers have made it into space? Made it into orbit? Let me put it to you like this. How many commercial providers made it into orbit? SpaceX was the first one to do it. Then who? Of course. Farouk's, I know a little bit about economics, but I'm not confident enough in my economic prowess to be able to teach it here. Boeing? Nope. Rocket Lab. They were the second one to do it. Firefly was third. Actually, Astra was third. Firefly was fourth. Only 4. That's it. Skip ULA. I'm talking about new space, Blue. That's clearly the context of conversation for the technical people. Yeah, that's clearly what we're talking about with context of conversation, but subtleties is not your strong suit, chat. How do you see the spaceflight industry maintaining 70 to 80 UES launches a year? By the way, holy crap. The recession that's very likely coming, I fear for Artemis. Artemis will be fine, Celia. It'll be fine. Congress wants it to happen, so it's going to happen. You're off by a couple. We're forgetting orbital sciences and the people who want. Okay. Yep, subtleties is not your strong suit, fellas, but that's fine. Okay, if you want to include orbital sciences, that's fine. You can include orbital sciences. You know, it's all about, you know, including everything. I understand. I'm talking about in the era of new space. That's the context of conversation. So there's only, even if you did include this, that's a handful of companies. How many companies are there? Even if we play devil's advocate for commercial companies that have made it into space. So let's do the whole picture. So you have Orbital Sciences, SpaceX, ULA. You have Astra, Rocket Labs, and Firefly. That's it. That's it. 7 companies. How many commercial startups are there? Let's just think of people that haven't made it into... Actually, Astra, too. So there's one more. I keep forgetting that their rocket actually worked one time. Forgive me. So how many commercial startups are there that say they're going to revolutionize the launch market? There's Relativity. There's ABL. There's... Who else is out? There's Spin Launch. You know, there's a bunch, dude. Northrop Grumman, I mean, technically, but that, I guess you could count Orbital Sciences with that. You know what I mean? Virgin Galactic actually made it too. Or not Virgin Galactic, Virgin Orbit made it too. Yeah, I forgot them for the new space flight one. Sorry. That's right. So, even then, that's still a handful of people, guys. The manhole cover? That was a government program. So, I learned a lot about rockets, but you got to go to bed. All right, CJ, no problem. So what's going to keep a market sustainable like this? You're watching a changing in the industry, Celute. Sorry, I forget where I was going with the other one, guys. I'm starting to get tired. The market could be sustainable, but yeah, okay. We're not at the point where space flight is sustainable yet. So any failures like this that happen are not good. That's not a good thing. That's what I was saying. Sorry, it took me a second. Starting to get tired. Nobody else ever had the balls, 8, to launch like Orbital Science did. Yeah. That's a bad joke, but I'm sticking to it. Loopy, that's bad even for you, dude. That's bad. That's bad even for you, man. Come on now. But anyway, the point that I'm trying to make is that, guys, failures like this is still bad. That's still not a good thing. Virgin Orbit promised at least 15 launches this year. They did 2. Talk is cheap, Forge. Dude, if I ever had an aerospace company, dude, I would not say anything. I would not be saying anything except to like maybe investors. Until, like, I have something to show. You know, we harp on Blue Origin for, you know, we harp on them for, you know, like, oh my gosh, you don't, you know, let us see what you're doing. But also at the same time, you know, they ain't going to show us something until they have something to show. And I kind of appreciate that. Astra said they were making 300 launches a year. Where are they? Well, they said that, and then they decided to shift their business strategy because failing 2 to 3 times in a row is not a good idea. Any clips? Boop, 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 boop. So it's hard to see. It's hard to see, but watch at 3:26. So in 3 seconds, watch right here. Boop. Yeah. The back fell off. They have a loss of control. The rocket is, yeah, that's... It's got to be Q&A, dudes. It's got to be. This has got to be QA. It has to. The Z4, the first Z4 that launched the disco ball into space on the first Vega launch performed perfectly. Yeah, look at that. That face is, oh, I will never financially recover from this. Not Q&A, QA. Oh, thanks. How often do you see SRBs fail like that? It's not very often, JSpeed. Omegas was a little bit different, Synerd. It was the opposite of that, but it ended up having the same effect. We're talking under versus over expansion, but yeah. Bob, Merry Christmas, buddy. Quality and assurance. Shutting and the frick up. They're cursed with QA problems. Remember when they attached cables in reverse for the 4th stage and it ended up doing a 180 and deorbiting itself? Yep. That sucks. That's not really how I wanted to end the night, but... What was the mission of Vega-C? Farouk, it was launching 2 Pléiades Neo satellites. What are Pléiades Neo satellites? They actually explained it.
Tonight, on board Vega-C, Europe's newest launcher, are a special set of twins, Pléiades Neo 5 and 6. These 2 very high-resolution optical satellites will join the rest of the Pléiades Neo family. The first 2 of these satellites were launched last year by Arianespace. The Pléiades Neo constellation, which has been entirely designed and built by Airbus, is a combination of unique technologies enabling imaging of the Earth several times a day at 30-centimeter resolution.
30-centimeter resolution? Oh god, that can't be cheap. Oh no!
This is a very important program for Airbus because it's paving the way to the growth of the future. It is bringing the 30-centimeter resolution to the constellation of Airbus. It is complementing Spot, Pléiades, and our other satellites. The 30-centimeter market is where you find most of the interest today for our Earth observation customers. This will help to generate more information.
No, this hurts, man. I can't watch this. Oh, God. They're nearly 500 million pounds a pop, so that's $600 million each. Oh. They'll build more. They probably have spares, Jim, to be 100% honest with you. You never... It's okay, so first rule of satellite production. You don't talk about satellite production, no. Jokes aside, if you have a constellation of 6 satellites, you usually end up building 8, just in case something like this happens. That's part of the insurance process. So you basically build 8 to make up for any potentially lost revenue. That's normal for the satellite industry. It's normal for satellite production. You're buying a 10-sat satellite network, buying 10 satellites, make 15, just in case something goes wrong. So they probably have more of these, but making more satellites also costs more money. But that's money that's already invested. So they probably do have more satellites. They probably already have them. They're probably in various stages of construction right now, even the spares. And then, best case scenario, right? Best case scenario, your 10 satellite network has 15, you have 15 satellites as a backup in case those satellites break. So best case scenario, you just launch all 15. That's how satellite operators work. SpaceX does that with Starlink. Intelsat does that with what the heck is the name of their network? I forget what Intelsat's network is. Eutelsat does that with O3b mPOWER. OneWeb does that. Everyone has spares. Iridium has spares. Everyone does that. That's just in case something like this happens. Wait, what happened? Ariane Space's Vega-C rocket malfunctioned on the way up, Sam. The second stage engine popped. Like, bye-bye. Intelsat is not Iridium. No, Iridium is their own thing. Yeah, I remember that failure, Forge. That was horrible to watch. So where's Tidris 4 in case of failure? Well, my mission went correctly, Hangman. Just saying. You want me to launch the spare? I'll launch the spare if you want, dude. Oh, my goodness. Is this the culprit? Let me see. No, this is the Zefiro 23. That's from Vega, not Vega 3. Or Vega-C, excuse me. Oh, that's so... Dude, it sucks, man. It's such a freaking pain. See, that's from Vega. Vega-C is the Zefiro 40 is what we're looking at right here. Pléiades Neo are mixed civilian military use satellites constellation. They absolutely have spares, Deadbringer. They also make additional satellites for debugging purposes if something goes wrong. Yep. Wait, weren't these originally planned as a Soyuz launch? No idea. Galaxy, thank you, weather guy. Yep. Hubble was a spare. Yep. Yeah, Vega E is very nice. Yes, let's launch the spare and end the night on a high note. Nah, this went way too late, dude. I'm gonna keep the shuttle up on orbit. We're gonna just drop a save and we'll bring Pathfinder and Foggy and Thomas back down tomorrow. Doesn't NASA still have a spare for Hubble? Nancy Roman. Yep, the Nancy Roman satellite. Yep. Why was Hubble a spare? It was a spare spy satellite, Vin. Anyway. Yeah, fellas, we'll leave the shuttle up there and we'll bring it back down tomorrow. We'll conclude that mission tomorrow. That Vega failure went way late. Is there footage or is there just telemetry data? There's footage, Geese, and they had a tracking camera on the thing when the motor popped, and then the telemetry correlated exactly what the picture was doing, dude. I'm telling you, it blew the nozzle off the bottom of the engine. Like, the whole nozzle gone. You barf bag. The bottom fell off. Yeah, no, Nate, seriously. That's so Vega-C's second stage is the Z4, the Zefiro 40. Guys, I'm so confident that it's the nozzle because this SRB has 3 moving parts. The igniter and the 2 thrust vector controllers. So we clearly lost the thrust vector controller. There was an explosion down here and we had huge plume under expansion. See this assembly from about here to about there, that got jettisoned out the back, and it wasn't on purpose. So something went wrong. That tells me that this thing wasn't seated in this thing correctly. Why? Why does it tell me that? It tells me it's not seated in the bottom of the casing correctly because the Zefiro 40 on the first Vega-C worked just fine. The rocket just doesn't go from working to not working. That's not how this works at all. That means there was a different configuration of the vehicle was established between this and the first Vega-C that launched. That's what happened. That tells me something was manufactured incorrectly down, not either A, manufactured incorrectly down there, or the Q&A and Q&A and Q&A and Q&A, no, or the QA guys missed something. It could be a manufacturing defect. It could be somebody didn't seat this correctly. It could be something wasn't torqued right. There's a bunch of different things. But yeah, they clearly lost the nozzle and their booster depressurized, meaning that basically from here downward was deleted. I got you a high def pic of the Z40. Yeah. Yeah, so basically from this piece down got bleeded pretty bad. Thank you for the picture. And that sucks. That sucks a lot. Failure in one of the gimbaling arms, perhaps? Well, that doesn't explain the plume under expansion, dead scum. And the failure was very abrupt. A TVC failure means the rocket would just kind of do this. It would just kind of flip over. Like the other Vega where they wired the stage backwards. Seriously. They inverse wired one of the thrust vector actuators on one of the previous Vega launches. And the fourth stage, instead of going up into space, went down to the ocean very quickly. Yeah, Rocket, that was hard to watch, dude. Sounds like nozzle failure. I'm not showing it, Forlorn. I don't want to watch any more failures tonight. That's why I didn't even bother trying to land my shuttle. I'll just do that tomorrow. There's too much bad juju. Rocket, we saw it. I noticed it probably about 10 to 15 seconds after it happened. I thought it may have just been something, and then I saw the telemetry and went, nope. 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 Sucks. I'm closing out the tabs, dudes. I'm closing out the tabs. I don't want 30 centimeter resolution. Oh, that sucks so hard, man. That's so difficult. Oh my god. It was pretty sudden and apparent. Yeah. That is not what Arianespace needed, dude. That's not what they needed. All right. Well, Rocket, that's going to do it for me. Oh, that sucks. Some poor whale is getting pelted with debris. All right. Fellas, yeah, we'll pop off. I'll see you guys tomorrow at noon. So we'll bring the shuttle back down tomorrow, and then we'll keep working on our station modules. But yeah, I don't want to touch Kerbal. It's too much bad juju. Yeah, Forge. Jeez. All right, have a good night, everybody. Let's raid Haas. Haas is doing some GTA RP. He's a good buddy of mine. Go over there and show him some love. Please, if you could just pop in and say, Haas raid! Or something like that. Just jump in and say hi. Trust me, I don't like going and raiding somebody and then have none of you guys say anything. Please just go over there and say hi. He's a good dude. He won't bite. At least I don't think he will. No, he's a Hoonigan guy. He's a good buddy of mine. Go over and see what he's up to. Let's give him the raid, and we'll go from there. I'll see you guys tomorrow at noontime. Thank you very much for watching. Have a good night.